one constant difference, like this one. This is a linear number pattern. So to find a constant difference, I told you you need to subtract your terms. Usually, when you get this problem on your question paper, when you find this type of question in your question paper, they will ask you to find the next two terms of the sequence. So, and they will also ask you to find the general term, the term that you will use to find any sequence or any number on this sequence. If they want you to find the 50th term, the 50th term of the 50th term of the sequence, you will use that general term. Welcome to MSP. Welcome, guys. Today, guys, I want to do sequence and series. I want to do sequence and series, so I will be doing a linear sequence, linear number pattern, guys. Yeah, I want to start with linear sequence, and then I will move forward to a quadratic sequence. Linear number patterns. So I know if you are in grade 10 or grade 11 or 12, usually they give you this. You come across this question in your question paper. So I want to show you guys how to do linear number patterns. So, what is a pattern, guys? What is a series? What is a sequence? You must understand the two, because a series and a pattern and a sequence are not the same things. So, a series, if I write numbers like this, 1 plus 2 plus 3 plus 4 plus 5, etc. And I write 1, 3, 5, 7, 9. And I write 8, 10, 12, 8, 10, 12, 16, and I write 2, 4, 6, 8, 10. The difference between these four series and pattern is that you can see here, guys, it's 1 plus 1, 1 plus 2 plus 3 plus 4 plus 5. This is a series. This is not a sequence. This is a series of numbers. This is a series of numbers. 1, 3, 5, 7, 9. This is a sequence. This is a sequence now, because there is a constant number between these terms. There is a constant number. Constant difference. We call it a constant difference. You can see we add 2 to get 3, we add 2 to get 5, we add 2 to get 7, we add 2 to get 7. So this is a sequence. 8, 10, 12, 14, 12. What is this? What do we get if we subtract 8 from 10? We get 2. It means we add 2 to get 10, we add 2 to get 12, we add 2. This is also a sequence. Two, 4, 6, 8, 10. You see, this is a series of numbers. But there is a difference. You see, there is a difference. Constant difference. There is a constant difference here. 10 minus 8 is 2. 8 minus 6 is 2. 6 minus 4 is 2. 4 minus 2 is 2. So this is a constant difference. This is a constant difference. This is a difference between our terms. This is a constant difference. So when we deal with what is this? Oh, it's a constant difference, and this is a sequence, guys. This is a sequence. This is a sequence. We have a constant difference, guys. A constant difference is it's a common difference, constant difference between our terms. If we subtract the larger term from this one, if we subtract 7 from 9, we get a 2 again here. So if you subtract 7 from 9, you get 2 here. If you subtract 5 from 7, you get 2, 2, 2. So you get constant difference between your terms. If you subtract the second term, if you subtract the first term from the second term. So when you subtract your terms, you will get a constant number. The number will be constant throughout your terms. It will be constant number. When you subtract any number from any number here in this sequence, you get the constant common constant difference. You see, it's common constant difference. So this sequence here, we have to identify if this sequence is an infinite sequence or finite sequence. It's an finite sequence or infinite sequence. Infinite and finite. This is an infinite. This is an infinite sequence. Why am I saying it's an infinite sequence? If you see these dots, it says this sequence doesn't end here. It continues to the infinity. So it's an infinite sequence. So this one is also an infinite sequence. Infinite sequence. 8, 10, 12, 14, 16. You see here, I didn't do those dots to show you that this sequence continues to the infinity. You see, it ends here on 16. Even this one, it ends here on 10. Yeah, so this is a finite. I don't know how to. Finite sequence. It ends. It doesn't go to the infinity. It ends here. It doesn't go. It doesn't continue to the infinity. So the number actually ends here. This is where they end, guys. So this is the types of patterns you need to know. But now we want to focus on this linear number pattern. What is a linear number pattern? A linear number pattern is a pattern that has a one constant difference. That has a one constant difference. It doesn't have a second constant difference like a quadratic sequence. It only has one constant difference like this one. This is a linear number pattern. So to find a constant difference, I told you you need to subtract your terms. Usually, when you get this problem on your question paper, when you find this type of question in your question paper, they will ask you to find the next two terms of the sequence. So, and they will also ask you to find the general term, the term that you will use to find any sequence or any number on this sequence. If they want you to find the 50th term, the 50th term of the 50th term of the sequence, you will use that general term. So let's go and find the constant difference here, guys. What is 9 minus 7? 9 minus 7 is 2. 7 minus 5 is 2. 5 minus 3 is 2. So now this is a constant difference. Common difference or constant difference. Common constant difference. I will put it that way. Common constant difference. So this is your general term for linear number pattern. It's 8n equals to n plus 8n minus 1 times difference times common difference. D is common difference. This is common difference. This is common difference. D stands for common difference. And then your n is the number of term. N stands for your term. Your term number. This is term 1. T1, T2, T3, T4, T4. So N stands for the term that you're looking for. If I'm looking for term 5, then here I will put 5 here. I will put 5 if I'm looking for term 5. I will show you right now. Let's go ahead. This is your formula, your general formula for the linear number pattern. So you use this formula to find the general term, guys. So you have a constant difference here. So if you have a constant difference, you know that you can use a shortcut. You can use a shortcut without using your what is this? Your formula. Because now you know that your constant difference will be the one that you multiply with the number of the term you're looking for. What am I saying? If for instance, I'm looking for, because it's 2n here. It's 2n, then you minus your common difference from the first term. So it's gonna be 3 minus 2. 3 minus 2 is 1, guys. So this is your general term for the sequence. You can substitute 1 here to see if you get 3. What is 2 times 1? 2 times 1 is 2 plus 1 then is 3. You see, guys. What is if you insert 2 here to find term number 2? Let me just substitute. 2 times 2 is 4 plus 1 then is 5. You see, 5, 3, 5. Then if you continue substituting 3, 4, 5, you will keep getting the next sequences, the next term of the sequences, guys, by substituting the number of the term you're looking for. If I'm looking for the 50th term of the sequence, I will insert 50 here. So if I'm looking for the 50th term, term number 50, if I'm looking for the term number 50, guys, I will substitute n with 50. 250 plus 2 times 50 is 100, and this is 101. This is the term number 50, guys. If I was looking for the term number 50. So in this case, they want you to find the next 2 terms of the sequence. So you can want the next 2 terms by just saying you put that, you add 2. You say 9 plus 2, then it's 11, and then you also add 2. 11 plus 2 is 13. You see, guys, you can do this. You can look for the next 2 terms of the sequence by just adding your 2, or you can use the general term. You can use the general term. So how do you use this general term to find? How do you use this formula, guys? Sorry, to find your general term. Because I showed you that you can just say, you know that if a constant difference is 2, then your general term will be 2. You multiply this 2 by the number of the pattern you're looking for, which is n. Then you will subtract 2 from this first term, then you get 1 here, positive 1. This is your term. So we have to get the very same term by using this formula. Let's go and use this formula. So it's n minus 1. Yeah, so let's go and substitute, guys. We're looking for the general term. So what is your A? First term of the sequence is 3 plus into n. We don't have n. We just leave it like that. Minus 1. D is 2. So let's go and simplify. What is 2 times n and 2 times 1? 3 plus 2 times n is 2n. 2 times 1 is 2 times negative 1 is negative 2. So this one is a constant number. This is also a constant number. 3 minus 2. 3 minus 2 is 1. So we got the same general formula. You see, we got the very same formula using 2 methods. You see, so you can, it's either you just do this, you know, if a constant number is 2 or 6, any number, you just know that if it's a linear number pattern, you know that your constant number will be multiplied by the number that you're looking for, but the number, the term that you're looking for, which is n. N stands for term number 1, number 2, number 3. It doesn't matter which term, but n stands for term. So it's 2 times n because our difference is 2. So we subtract the first term from, we subtract the common difference from the first term. So it's 3 minus 2, it gives us positive 1. That's how I get my general term when I'm dealing with a linear number pattern, guys. Easy stuff. Okay guys, I have this pattern now. It's 2, no, it's 4. It's 4, 8, oh, it's 4, 6, 4, 6, 8, 10. 4, 6, 8, 10. 4, 6, 8, 10, guys. Yeah, this is our linear number pattern. So the question here, it says find the next 2 terms of the sequence. Find the next 2 terms of the sequence. So first thing you're gonna do, you start by looking for your constant difference, your common constant difference. You will subtract this from this. You'll subtract 8 from 10, 6 from 8, 4 from 6. That's how you look for your constant difference. So 10 minus 8 is 2, 8 minus 6 is 2, 6 minus 4 is 2. So this is our constant, common constant difference. Common constant difference. In our formula, this stands for A. The constant difference. So we found our constant difference. It's A. It's 2, I mean. So they want the next 2 terms of the sequence. As I told you before, you will add 2. 10 times 2 is 12. 12 times 2 is 14. We got our first 2 terms of the sequence, our last 2 terms of the sequence. This is, then you get at least 2 marks for this. And then they say write the general term of this sequence. General term of the sequence. If you hear general term, find the general term of the sequence. You remember this equation. Remember this equation. Oh, it's n minus n minus 1 times common difference. Remember this equation. You can use this equation. What is your A? Your A is the first number of the sequence. In this case, it's not a constant difference in linear number pattern. So your A is the first term of the sequence. It's 4. We want the general term of this sequence. We got the last 2 terms of the sequence. Now we want the general term. N. We don't write anything here. 1. Common difference is 2. 2n minus 2. So this is 2n plus 2. This is your general term. 2 times 1 is 2 plus 2 is 4. 2 times 2 is 4 plus 2 is 6. 2 times 3 is 6 plus 2 is 8. This is the general term. So the other way, if you don't want to use this formula, you can use the method that I showed you guys. If you have a constant difference like this, to find your general term, you just do this. You know that if it's 3 or 6 or 2 here in this case is 2. So you will just say 2n, because you know that you will have to multiply your common difference with the number of the term you're looking for. So it's 2n. 2n then plus something. How do you get that plus something? You see, this is the first term. It's 4. 4 minus 2 is 2. Then here is plus 2. Then you get the general term, like this one. You see, guys, easy, man, easy. Easy. You don't even have to claim this. Easy. So that's it, guys. This is how you find your general term when you deal with linear sequence. There is an arithmetic sequence and there is a geometric sequence, guys. So now, me here, I'm showing you arithmetic sequence. I don't want to show you geometric sequence and arithmetic sequence at the same time. I will make another video showing you a geometric sequence. So let me do the last example, guys. The last example is 2, 10, 18, 26. Write down the next 3 terms, the next 3 numbers in the pattern. Oh, they want the next 3 numbers of this pattern. This pattern, is it infinite or finite? Is it a infinite sequence or a finite sequence? It's an infinite sequence because it goes to the infinity. It continues to the infinity. It doesn't end here. It can go to the infinity. So this is an infinite sequence. So to find the next 3 terms of the sequence, every day, every time, this is what you do. 10 minus 2 is 8. 18 minus 10 is 8. 26 minus 18 is 8. 26. Then the common difference here is 8, guys. 26 plus 8 is 34. Is 34. Then 34 plus 8 is 42. It's 44, guys. Sorry. It's 44. Oh, that is 34 plus 8 is 42, guys. I added. It's 42. This is 42. Yeah. So now we have our common difference. It's 8. We can look for general term now. Remember, how do you look for general term? You can use your formula, or you can just, do this. This is 8. Then it means here it will be n times 8. So you say 2 minus 8. 2 minus 8 is minus 6. Then this is minus 6. This is your general term. Before we can look for to prove, you can just substitute 1 here, and if you get 2, then it's right. Let's go and find this general term by using our own formula. The formula for general term. This is the formula. This is the formula. So let's go and substitute. This is the first term of the sequence. It's number 2. So this is 2 plus into n minus 1, d is 8. So we multiply to remove this bracket. 8 times n. 8 times n is 8n. And then 8 times minus 1 is minus 8. So what is 2 minus 8? 2 minus 8 is minus 6. The same general term by using 2 methods, guys. It's up to you. It's either you use the formula or you use this method. The one that I did here. It's up to you. So this is a linear number pattern, arithmetic sequence. I hope you get it, guys. So on our next video, I will be showing you quadratic sequence, guys. First thing, when you do quadratic sequence, guys, quadratic sequence. If you do quadratic sequence, yeah, let me just do this quadratic sequence. So a quadratic sequence differs from a linear sequence by our common differences. In a linear sequence, we have one common difference. So in quadratic sequence, we have two common differences. The other difference is not common. It's a constant difference, but it's not common. Let me show you what I'm talking about here. So what is 7 minus 4? What is 7 minus 4? Is 3. What is 12 minus 7 is 5. 19 minus 12 is 7. What is 7 minus 5 is 2. Then here is 2. This is a quadratic. You see, quadratic sequence, it has a second, we call it a second common difference. Second common difference. It's a second common difference. This is a first difference. It's not common, but it's a first difference. We have first difference and a second common difference. This is how you identify if your sequence is quadratic or it's a quadratic. If that's how you identify your sequence, if it's a quadratic sequence, guys, this is how you see it, because we have a second common difference. So in this case, we won't use the very same methods we used when we find our general term on the linear sequence. Quadratic sequence, it operates in a different way. So in this case, our general term, we have a formula for general term. So in this case, our general term will have it's a quadratic, will have a square like this. This is a quadratic formula. We have an squared plus bn plus c. This is a constant number. This is n stands for the number of the term you're looking for, and this is a constant. It's a first. This is a first